chemistry topic for first BSc, the chapter liquids and solutions. In this content, we are going to discuss surface tension, effect of temperature and solute on surface tension, Paracar-Suchen equation. Now, to understand that, the learning objectives are meaning and expression of the surface tension and Paracar, applications of Paracar. Session outcomes will be definition of the surface tension and Paracar, application of Paracar. Prerequisites. These are all the things you have to know before understanding the content. Properties of liquids, interaction of liquids, structure of a molecule. When you come to the properties of liquids, how the liquids are arranged, how they will flow, what are the intermolecular attraction it will be having, all this you have to know. Now, interaction of liquid. Interaction means during the liquid flow, what are the interaction it can take place. Those things you have to know. Now, structure of molecule. In this, structures of the molecule. When you write the molecule, you will be writing some structure. Structure may be octahedral structure, trigonal structure, trigonal bipyramidal. All this structure can be written, and we will be having some molecular structure for particular molecules. All these things you have to study under the structure of molecules. Now, let us see what is the surface tension. The existence of strong intermolecular forces of attraction in liquids gives rise to another important property called surface tension. It is defined as force in Newton acting at right angles along the surface of the liquid 1 meter in length. Surface tension of a liquid account for spherical shape of a drop of liquid. It is also responsible for rise of liquid in capillary tube. This you people have observed in the burette and also in the pipette. The drops, whatever it is coming out from the burette, that is due to the surface tension in the capillary. That is at the bottom of the burette, you can observe the drops, how it can come. That is due to the surface tension. Now, what is the factor? Effect of temperature on the surface tension. Kinetic energy is directly proportional to absolute temperature. As temperature increases, energy of the molecule increases and the intermolecular forces of attraction decreases. It is obviously with increasing in the temperature, the intermolecular forces of attraction decreases and molecular motion increases with increasing a temperature. That is, with increasing a temperature, the molecular movement increases due to the intermolecular forces of attraction decreasing. Thus, surface tension decreases with increasing a temperature. At critical temperature, the surface tension is 0. Now let us see the next parameter. What is the effect of solute on the surface tension? A number of substances when added to water lowers its surface tension. These substances are called as surface active agents. So surface tension can be reduced by adding some substances. Thus, liquids like methanol, ethanol when added to acetone and acetic acid when added to water lowers its surface tension. That is, methanol or ethanol added to acetone, it lowers the surface tension, and acetic acid when added to water, it also lowers the surface tension. Similarly, day-to-day life we have observed the soaps and detergents when mixed with water lowers its surface tension. So produces the surface tension of water by disrupting the hydrogen bonds between the water molecule. You would have observed when you're washing the clothes. So soaps and detergents, when you mix with the cloth, soap and water reacts there, detergent and water reacts there. First there will be a separation of the molecules, that is the dust particle will be separated by the water molecule because it lowers the surface tension of the water. Next we'll see what is called as paracar. Paracar is a molar volume of the substance at a temperature at which surface tension is unity. Unity means it is 1. When the surface tension is 1, the molar volume of the substance at a temperature will be equal to 1. The surface tension of the paracar or a molar substance will be equal to 1. Now this is also called as Sturgeon equation. This is capital M gamma to the power 1 over 4 divided by rho minus rho dash, or this can also be equal to capital M into C, or this is equal to P, that is called paracar. The P should be written in the square bracket. It is called paracar. M is the molecular weight, C is the McLeod's constant. What is this rho? Rho is the density of liquid and rho dash is the density of water vapor and gamma is the surface tension. Now let us see the application of this Sturgeon equation. So as I told you that prerequisite, we have to know the structure of the molecule. For that we have considered one molecule here, for example benzene. So benzene molecular formula will be C6H6. It is having alternate double bond and single bond, 6 carbon atoms and 6 hydrogen atom. This is the structure according to the Kekulé. Now this 6 carbon atom, 6 into 4.8, it is the bond length, that is equal to 28.8. 6 hydrogen atoms is equal to 6 into 17.1, 102.6. 3 carbon-carbon double bonds. You can see in the diagram there, it is 3 into 23.2 is the bond length of the double bond, that is 69.6, and 1 6-membered ring, that is 1 into 6.1, it is equal to 6.1. When you sum up all these bonds, now you will get total is equal to 207.1. Now let us compare this structure with the paracar or Sturgeon equation. As I told you, the Sturgeon equation, the square bracket P is equal to M, capital M, gamma to the power 1 over 4 over rho. Now the rho dash is negligible, which is equal to the molecular mass or molar mass of the benzene is 78 gram per mole, and gamma, the surface tension at 293 Kelvin, which is equal to 29.3 dynes per centimeter. Now the density rho is the density of the benzene at 293 Kelvin, which is equal to 0.878 gram per centimeter cube. By substituting all this value in the above Sturgeon equation, we get the value, the total value or paracar value is equal to 206.69 per centimeter cube. Now, from these above two values, these are all in agreement with each other. That is, first one, what are the values we have got? That is 207.1, and now it is 206.69. So from these two we can say that it is supporting the Kekulé structure, that is paracar structure or Sturgeon structure supporting the Kekulé structure. Hence whatever the structure we obtained for the benzene is correct, according to the Kekul as well as according to the Suchen. Now we'll come to the next diagram or structure, the structure of quinone. We can write the structure of quinone as shown in the diagram. This is the paragraph for structure 1. For 1, this is the structure 1. I am showing this structures. That is, it is also containing 6 carbon atom and 4 hydrogen atom, 2 oxygen atom, 4 double bonds and 1 6-membered ring. So total will be 236.1. Total value for this structure quinone will be 236.1. Now let us see the other structure of quinone. Now it will be having 6 carbon atom, 4 hydrogen atom, 2 oxygen, 3 double bonds and 2 6-membered ring. Can you see in the diagram? 2 6-membered ring. Now the total value will come to 219. Now the above structure will give you 236.1. The next structure will give you 219.0. This is the molecular structure. From this you can observe that the observed paracar value for the quinone is 236.1. Now when compared to the structure 1 and structure 2, you can judge that the structure 1 for the quinone is correct. The structure 1 is correct. But you can't write the structure of the quinone like this as you shown in the second structure. This structure is invalid, whereas the above structure, structure 1, the quinone structure can be written like this. So this is what the comparison between the two quinone structure. It has been studied under the paracar. Now next will be recapitulation. What and all we learn now? Definition of surface tension, mathematical expression in unit, the factors affecting surface tension, paracar, Suchen equation. Thank you.